Right. Next, Vishal Subedi.
Hello everyone, I'm Vishal. Today I'll be talking about the classification of violent anti-government conflicts in Mexico using machine learning. This was done under the guidance of my advisor, Dr. Chatterjee, along with my colleagues Harsh and Soumya. Ben provided us with the political conflicts data from Mexico. As we all know, Mexico has had a long history of violence, be it electoral, political, or rebel-based. According to the Aglet Conflict Index, Mexico is the third most conflict-prone country in the world after Syria and Myanmar. According to the NORIA database, 61% of the political violence in Mexico has been caused due to firearms. A recent report by Statista shows that the homicides related to drug violence have been increasing and have reached an all-time high. As more and more data related to political conflicts and electoral conflicts become available, data mining and deep learning models could be made more robust using these data sets. Here are the challenges that we'd like to address. The data is spatio-temporal, so it's not IID, and the neighboring samples are correlated spatially as well as temporally, and data set is sparse. It's well proven in literature that the application of classical machine learning models on a spatially related dataset produces salt and pepper noises. The dataset is also highly imbalanced, so these problems make it more challenging and unique. So here are the objectives that we'd like to achieve. So we'd like to develop a generalized methodology that can help model these kind of spatiotemporal data. We'd also like to analyze the spatiotemporal patterns. And finally, we'd like to find the important set of predictors that are driving the political conflicts in Mexico. Talking about the dataset, it's a tabular dataset which has two different kinds of variables. One is the demographic based and other is text based. The demographic based data includes but not limited to homicides, accidents, suicide. And similarly, the text-based data includes, but not limited to document data, like the counts of abusive or unique words between citizens. There are 6 lagged files, each having 1200 variables and around 500,000 samples. The response is a binary type, where one shows the presence of at least one material or verbal conflict in that particular spatial location. The dataset encompasses 32 states of Mexico, having around 2,400 municipalities. The time frame of the data is from 2003 to 2020. There are some of the variables which are not available until 2003 end. Apart from that, there are some missing completely at random data. In the first phase, we pre-process the data and convert the tabular data into a 3D matrix where the axes are space cross time cross the number of predictors. We also undersample the data by removing some of the municipalities that did not see any minority counts. So, and finally, we fit a weighted random forest model and a deep learning model on the original data as well as on the undersampled data. So as we can see on the original data, the random forest model is performing much better than the deep learning model. On the undersampled data, there is a significant improvement on the weighted random forest model, but the deep learning model is still struggling. In the phase 2, we identified the k important lags and used those lag predictors to fit 3 different voting classifiers. The first and second voting classifier have very similar F1 score, but the third one is barely matching the F1 score. The time series model from the previous phase was not very reliable. And we also need to focus more on important predictors rather than just the lags. Also, the voting classifier from the previous phase, which is performing the best, still has a very large feature space. So this makes the model complex and prone to overfitting. So in the third phase, we use various feature selection methods, train them on a random forest, tune them using a tenfold cross-validation, and select the best method. So turns out that the lasso 100 simulations is the best method. Using the variable selected using lasso 100 simulations, we fit 4 different machine learning models. Tune them on the tenfold cross-validation, fit a voting classifier using soft voting, evaluate them on the test set. Finally, we use the random forest model to extract the feature importances. So these are this is the result from the previous phase. As we can see, the baseline lasso is selecting over 400 features and has an F1 score of 35%. But on the other hand, the lasso 100 simulations is just selecting 82 variables and has a very comparable F1 score. Talking about the voting classifier, it has got an F1 score of 41%, which is the best among all the previous phases. One other thing to note over here is that the recall has significantly improved from the previous phases. This plot over here shows the feature importance extracted from the random forest model. So over here, as we can see, year and month turn out to be the most important. But one thing to note over here is that although year and month turn out to be important, they independently do not carry any information. They are most probably confounded with some tragic events or a notorious phase that took place in those months and years. Apart from that, the accidents, the material conflicts, the homicides, and the positive sentiment score turn out to be the important variables. The plot on the right shows the spatial distribution of the conflicts. The red shows the presence and the green shows the absence. So using the extended global Moran's index, we concluded that the spatial correlation is not significant. On the left plot, we can see the presence of clusters in the data, which has been identified using local Moran's index. Finally, we conclude that classical machine learning models are outperforming the deep learning models for the tabular data set. Also, the univariate time series analysis revealed only previous 1 lakh dependency, using which we fit a voting classifier, which performed the best in that particular phase. The feature selection method using lasso 100 simulations selected just 82 features, which when used with a voting classifier gave an F1 score of 41%. As we saw, year, month, accident, material conflicts, and the presence of positive sentiments turn out as the important predictors that are driving the political conflicts in Mexico. Finally, we concluded that the spatial correlation is insignificant using the extended global Moran's index, meaning that the samples could be treated as IID tabular dataset. These are the references that I used for my work. If you have any questions, you can find me after the talk. Thank you so much.